This is your review for Module 4. In the first one, we're supposed to find if the following is a function. In problem A, we do not have a function because the input 2 sometimes outputs 5, sometimes outputs 11, so it's not a function. For B, every single input is distinct. We must have a function. In example C, each input has a distinct output. Now, an input of 6 and an input of 8 each give me a 4, but this is okay. So yes, we've got a function. For D, the fact that -1 and 1 each point to 1 is okay. The problem lies here. When 1 gives me an output of 1 and when it gives me an output of 9, that means I don't have a function. Number 2, what is the fourth term of the sequence defined by the following? Well, we see we've got an explicit rule. So f of 4 is equal to 5 times 4 minus 6. We could just plug in our position number. Our fourth position is equal to 5 times -2. And we have got an answer, or an output, or a term of -10. Number 3, the first term of the sequence with the recursive rule given is 2. So choose the following. So let's make a table. Position number and our terms. Position numbers, we will do 1, 2, 3, and 4. I know I need to go as high as the fourth term. The first term is given as 2. And now with the recursive rule, you always use, when you're going for the second term, you will plug in the value for the first term. So let's do this operation. We've got 3 times 2 minus 3. So 6 minus 3 is 3. Now to get the third term, I will use the previous term of 3. 3 times 3 minus 3, that's 9 minus 3, which is 6. And now to get the fourth term, I'll use the previous term of 6. 3 times 6 minus 3, that's 18 minus 3, which is 15. Now that we have our table filled in, the second term is 3. That's true. The third term is 7. That's false. And the fourth term is 15. Yes, that's what we got. True. Which explicit function defines the sequence? Well, we could try just plugging in to each one of the choices to get our answer. But before we do plug in, let's rule some out. I see that my common difference is 3. So I'm going to rule out these first two. C and D have a common difference of 3. Now let's see which one works. Let's try C. So I'm going to plug in my f of 1. Does that equal 3 times 1 minus 5? Not does it equal, excuse me. I'm trying to see if I get a -2 for my term. So that's 3 minus 5, which is -2. And yeah, it's checking out. Let's check one more while we're at it. Let's do the third term. So for the third term, I've got 3 times 3 minus 5. And that would be 9 minus 5, which is 4. And yeah, when I put in a 3, out comes a 4. So C is the correct choice. Is each of the following an arithmetic sequence? Well, it's arithmetic if the common difference remains constant. It's +1 every time here. So yeah, that's an arithmetic sequence. It's not the same amount here. I've got a +5, but now I've got a +10, and I've got a +15. So no, it's not arithmetic. I'm going up 9 here, but then I'm going down on this next one, so it's not arithmetic. On this one, I'm going up 1.5 and up 1.5 and up 1.5 every time. So yes, that's arithmetic. Number 6, write the recursive rule for the sequence 16, 13, 10, and 7. First, we notice that our D, our common difference, is a -3. We're going down 3 between each term. The recursive rule always starts with the given first term, which we see is 16, semicolon. Now we're set to get our terms. So here's the real rule. To get any term, we take the previous term and we subtract 3. Isn't that how we get it? From 16 to 13, we take 16 and minus 3. To get to the next term, 13 minus 3 is 10. And that's what this rule says. And this rule applies for every position number greater than or equal to the second position. For 7 through 9, we'll use this table when they want the common difference in this sequence. Well, normally to get the common difference, you just find out the difference between your terms, which in this case is 12. However, we need to look up here because we're not counting by ones in our position number. We've got a difference here of 3 each time. So our common difference is 12 divided by 3, which is 4. We're going up by 4 for each term, but just notice we skipped some terms. We went 3, 6, 9. Where's 1, 2? Where's 4 and 5? So the common difference between each term is 4. And now we'll write the explicit rule. Well, the explicit rule starts with f of n. It tells you how to get every term. The first term, if we were to go back, the first term is not 14. Go back. If I wanted to get to the first term, I'm going to need to make a table, which I've paused to start right here. And I've got some of the information from this table already into this table. And I discovered my common difference is 4. That means the previous term was 4 less. And the term previous to that was 4 less, which is 6. So I know my first term is 6. And I will add to that my common difference times n minus 1. And that's how you write the explicit rule. You start with your first term. Then you add to that your common difference times n minus 1. N minus 1 represents the previous term position. And then find the elevation after 21 minutes. So what they're asking for is f of 21. That equals 6 plus 4 times 21 minus 1. Well, 21 minus 1 is 20 times 4 is 80 plus 6 is 86. So 21 minutes yields an elevation of 86. And did they give us any units on this? I don't see units. It might be feet. A problem like this would normally tell you the units. So look for that in an answer like this on your quiz. Number 10, Eric pays an income tax of 20% on his annual income. In the past 4 years, Eric had the following annual income: $3,000, $4,200, $6,500, and $5,800. Find a reasonable range for his income tax during these years. Well, the numbers given here are essentially our domain, although I would reverse the order and put them in numerical order. The range is found just by multiplying by 20%. So I'll show you how I calculate the first one. It's 0.20. That's how you write 20% times an income of 3,000. 20% of 3,000 is 600. So I can do most of that in my head. 0.2 times 4,200 is 8,400. 0.2 times, now I'm going to use this one, times 5,800 is 1,160. Got to double check my calculator. And for the last one, 6,500, I get a 1,300. And this is my range of his income tax. I took 20% of each one of his earnings. But first I put his earnings into order. Number 11, the fifth term of the sequence with the explicit rule. And here's our explicit rule. We're supposed to find the fifth term. Explicit rules are the easy one. They want us to find f of 5. That means for n, we will plug in a 5. 5 plus 6. And I'm going to put this n in a horizontal denominator. Oop, but I can plug in for that n. What did we say n was? We're looking for the fifth term. N is 5. So we've got 11 over 5. And it's that simple. Number 12, a sequence is defined by this recursive rule. The first term is -5. Write the first 5 terms of the sequence. So let's make a table. My term positions are n. My terms are f of n. The first term is given. And they want the first 5. So we'll do 1 through 5. 2, 3, 4, 5. With recursive rules, you always need to use the previous term to get a new term. So we're just going to plug that in. I'll write it down for the first one. F of 2 is when I take my previous term of -5 and add 2 to it. And I get a -3. But now I can see, just to get each successive term, I'll add 2 to the previous term. Get a -1, get a 1, and get a 3. In part B, we are asked to graph that sequence. So our term position is 1. We're at -5. I'm going to have to estimate. This is -6, so -5 could be here. And the second is -3. The third term is -1. Fourth term is 1. And our fifth term will be 3. And notice that these are linear. Means I must have done something right. So for 13, they want us to write a recursive rule for this sequence. First, let's identify our common difference. Looks like we're going up by 9 every time. So D is equal to 9. When we write our recursive rule, we first start off with our, okay, so we're set to write our rule. A recursive rule always starts with giving the first term, which in this case is -13. Put a semicolon. Now we can write the rule for getting all the other terms. To get all the other terms, you take, let me make some space right here. We know our D is 9. We take the previous term, f of n minus 1, and we're going up by 9, so we add 9. It's that simple. And remember, this rule applies for every term position number greater than or equal to 2. Now we can turn this into the explicit rule. In the explicit rule, we start with the first term. We actually use it, and then we add to it our common difference, which was 9, multiplied by n minus 1. That's it. Samantha on number 14 is saving her allowance to buy a $55 video game. The total amount she's saved in dollars, Y, and the number of weeks, X, is represented in the graph. And they want us to find the common difference. I took a minute on this problem to write these points as ordered pairs. But you don't really need to do that. You can see as we count by ones in our weeks, we're going up +6. So I know my common difference is equal to 6. And they want us to write a recursive rule. Well, in the recursive rule, we always start with stating the first term, which in this case was 6. And then we write the rest of the rule to get any term after that. We take the previous term and we add 6. That's what we did here. We went up by 6. We added 6 every time. And this rule applies for every position number 2 and greater. Now to turn this into the explicit rule, the common difference now becomes our multiplier. And we start with getting every term. F of n is equal to our common difference times n minus 1 plus 6. This 6 here is our first term. I could have written it this way. F of n equals 6 plus 6 times n minus 1. That would be consistent with the way I did on other problems. That's another way to put in the answer for part C. For part D, in 8 weeks, how much will Samantha have? Well, we're just going to plug in our 8. F of 8 is equal to 6 plus 6 times 8 minus 1. So it's 6 plus 6 times 7. And in this case, we get 48, and that would be dollars. Does she have enough to buy the game? No, because she needed $55. So that's the end of your review. You might want to do each of these problems again and study your notes.